Yeah. Yeah, good evening all. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not, right?
Yes, it is clear and visible.
Fine, thank you. So yes. So as part of today's myself, I'm Vijay. Like I hold nearly 17 plus years of experience, which includes 8 plus years of experience in Hadoop and Spark environment, right? So as part of today's demo, I'll be covering the following topic. What is big data? Why Hadoop required? Drawbacks with the current databases and Hadoop advantages and Hadoop scope and job market, right? And what is Spark and why PySpark required? So both Hadoop and Spark, PySpark both will be covered as part of this course. So first, like Hadoop and what is Spark, what is PySpark, need for PySpark, real life usage of PySpark and PySpark job market, right? Yes. Yes. Starting with the big data. What is big data? So like, see, like we got KBs of data, MBs of data, or GBs of data. See, you should have seen KBs, MBs, GBs of data, or even TBs of data, you should have seen. But petabytes of data, exabytes, zettabytes, right? Yes. But do you think petabytes of data or exabytes of data, is it getting generated in the current real world? If so, examples of petabytes of data generation. Examples of petabytes of data generation. Anyone? Examples of petabytes of data generation.
Yeah, Facebook.
Yeah. So we have got Facebook, like social media, like Facebook, right? Generating huge data means millions and trillions of users for Facebook. Millions and trillions of users, right? In a minute, how many posts and videos are getting circulated? Each and every post and video has to be stored, right? Huge data is getting generated. Take in a minute, but if you take hour, if you take per day, per month, huge data is getting generated. Not only like Facebook, right? Many applications are generating data, right? We talk about 1 minute to transaction, right? If you take 1 minute to transaction, so like huge data is getting generated, like talk like Facebook generating huge data, Twitter tweets keeps on generating. Next, like Google queries, right? Google queries. And YouTube videos upload. What should be the storage capacity to store all the videos? And email messages, email or Gmail messages. And we talk about bank transactions within the city. Within the city, you can see like hundreds of branches for a particular bank like SBI. Within the state, we see thousands of branches. Within the entire country, we see lakhs of branches for a particular bank like SBI. Within each branch, lakhs of branches. Each branch has got millions of customers making multiple transactions per hour, per day, per week, and month. So huge transactions, huge data is getting generated. Even for telecom transactions and even for e-commerce sites like Amazon, Flipkart, right? Huge data is getting generated everywhere, right? So on an average, Google generating more than 450 petabytes per month on an average. Means 450 into 1024 TVs. The data generated by Google on an average, right? So here currently we have got a databases, right? Like Oracle, MySQL, SQL Server, DB2 for OLTP, online transactional processing for day-to-day operations, right? Can store GBs of data. But what some specialized databases like Teradata and Netezza, Vertica, right? These Teradata and Netezza, Vertica, they're used for online analytical processing for data warehouse, right? TBs of data, can store TBs of data, right? Yes. Okay. So for handling petabytes of data, exabytes are higher than that, right? We doesn't have proper storage and processing systems. To handle huge data like above petabytes and above petabytes, we doesn't have proper tools, right? As a solution to all the storage level problems and processing level, right? We have got a framework called Hadoop, which is meant for storage and processing, which is meant for both storage and processing. Yes, 1 second. So here, before I go with Hadoop and Hadoop services, right, I will be discussing how this data is generated and what are the sources of data, what are the types of data. This is your data. Assume this is your data in the current real world. This is your data in the current real world, which has been generated from the last 50 years, which has been generated from the last 50 years, from 1973 to 2023. Nineteen 1973 to 2023. Yes. For example, from the last 10 years, 2013 to 2023, that is last 10 years, comparison with the previous 40 years. Last 10 years, comparison with the previous 40 years, right? Nearly 80% of the data what we see in the current world has been generated from the last 10 to 15 years. And only 20% of the data has been generated from the previous 40 years, right? Previous 40 years, only 20%. But last 10 to 15 years, 80% of the data has been generated. Reasons for this huge data generation: because of usage of technology, because of usage of technology, because of usage of smartphones, because of usage of internet. Huge data is getting generated, right? Usage of technology, usage of smartphones, usage of internet, right? Yes. Okay. And what are the main sources from where this data has been getting generated, right? Mainly three sources of data. Three sources of data. Social data, machine data, and transactional data. Social data means data which got generated from social sites like Flipkart, Amazon, WhatsApp, Facebook, all this, right? Data generated from social websites. Machine data means data which has been generated by reading or scanning the barcodes, RFID chips. Means for example, if you go to a shopping mall, for the items you purchased, right, a big bill is generated, right? Yes. Yes. So the data which has been generated by reading or scanning the barcodes or RFID. And transactional data which is generated from day-to-day transactions, by bank transactions, telecom transactions. And they have got three types of data. Data is into three types of data. Structured data, yes. Semi-structured data, yes. And unstructured data. So unstructured. Structured data, semi-structured data, and unstructured data. Data, three types of data. Means data which is generated from the data. Structured data means example of the structured data means data which has been generated from Excel files, DB tables, right? Excel files, database tables. Data which we generated from Excel files, database tables, such kind of data we call it as structured data. Semi-structured data, what is semi-structured data means not fully structured, not fully unstructured. Like XML files, JSON files. Unstructured data, right? Yes. Like articles, short messages, images, videos, right? So these are the sources of data. These are the types of data. So as day by day, data is increasing enormously. As day by day, data is increasing enormously, right? We need to have proper storage and processing systems. So we need to have proper storage and processing systems, right? For storing and processing this huge data. So for that, we have got a framework like Hadoop. Generally, any technology is meant for either storage or processing, but Hadoop is meant for both storage and processing. It stores and process.
You mean to say this is a database when you say storage,
Yeah. See,
like Oracle or Teradata?
one second. So if you take any technology, right, they are meant for either processing or storage. For example, if you take C or C++ or .NET, all they are meant for processing. Okay, if you got Oracle, MySQL, DB2, all these are meant for storage. But Hadoop is meant for both storing and processing. But for storing data, does Hadoop use any databases internally? For storing the data, does Hadoop use any databases internally? Means no. Hadoop doesn't use any databases. Hadoop doesn't use any databases for storing its data because databases has got some drawbacks. Databases has got some drawbacks. Despite of these drawbacks, still Hadoop doesn't use databases for storing its data. So it is going with a kind of file system called as Hadoop distributed file system. So databases has got some drawbacks. So Hadoop doesn't use any database for storing its data. So it's going with a kind of file system called as Hadoop distributed file system. And for processing, it is going with an execution model called as MapReduce or Spark. So we are going with a processing execution models called MapReduce Spark. So here for storage, a file system Hadoop is using, yes. And for processing, so hope you understood, right? What are the services of Hadoop? Storage and processing, stores and process. The two huge data, unlimited data storage is possible in Hadoop and processing this huge data in quick time, right? Yes.
So Hadoop is what we call Hadoop is a technology, or what do we exactly we say this one Hadoop is.
Hadoop is a technology, it's a framework, right? For storing and processing.
MapReduce is another name of Spark, or it's a different, both are different components?
No, both are different components. MapReduce and Spark, both are meant for processing.
So we have to use both, or anyone is fine for processing?
So MapReduce, okay, previously we used to use a lot, right? But now Spark is mostly used.
Okay, thanks.
MapReduce we used to use a lot in 2013, 14, 15, 16, 17, right? MapReduce has got a great boom, but once Spark has come, Spark is mostly used now.
So now this
Means still MapReduce is used. So I'll also give a knowledge on this MapReduce, but mostly like Spark is preferred, right? So Hadoop distributed file system is for storage, for storing that unlimited data. We can pull data from databases, from different databases, from different branches in different cities. We can pull the data and we can store in one place like HDFS. Okay, fine. So, okay, you may get one query, right? Whenever Hadoop is going to perform storage and processing, but what is the necessity of this processing and storage technologies then? Understand this? When Hadoop is able to perform both storage and processing, what is the necessity? What will be the necessity of this storage and processing? Do you think these technologies will be going away from the market when Hadoop is able to do both? So you need to clearly understand Hadoop is used for what purpose, right? Hadoop is meant for batch applications. So there are two types of applications, online applications and batch applications. So observe here, Hadoop is meant for storage and processing. Yes. For storing data, HDFS, for processing MapReduce Spark. So there are two types of applications. Hadoop is meant for batch applications. Hadoop is meant for batch applications. Batch applications, but not for online applications. For a single, right? Not for online. For example, you made an online transaction. For a single transaction, Hadoop is not required. For one transactions, two transactions, no. For millions and trillions of transactions, okay. For trillions, so we go for. So there are two types of applications: online applications and batch applications. Online applications means User interactive applications. User interactive applications means user provides the input here. Compulsory user has to give the input. Booking a movie ticket. Yes. Making online transaction, booking a movie ticket, right? User non-interactive applications. User non-interactive applications, right? Means here user doesn't use input. User doesn't provide input. Here user is nowhere required. Example, PNR status, railway ticketing PNR status, right? Currently your status is 200. After 1 hour it is 150. Tomorrow morning it's 100. Tomorrow evening you got confirmed. Means it is happening, right? Without the user interference, right? Yes. Credit card statements for millions. Credit card statements generations for millions of customers. Credit card statements generate for millions of customers. Or phone bill statements, right? Mobile bill statements generation for millions of customers. All this happens without the user input, right? Most of this are batch applications, right? Most of these financial and commercial applications, right, are batch applications which happens in the background. So Hadoop is also meant for batch applications, not for online applications. If you want to perform online applications or online, that even Hadoop will integrate with NoSQL database like HBase or MongoDB, right, and performs online processing also. Drawbacks with the current databases, right? Drawbacks with the current databases. First thing, limited storage, GBs or in TBs. Okay, 1 second. Let me say the drawbacks of the current databases. Drawbacks of current databases means first thing like limited storage. First thing is what? Limited storage in GBs or in TBs. In GBs or in TBs. But huge data like unlimited data storage is not possible with the databases. Limited storage in GBs or in TBs, and secondly, right, no parallel processing in most of these databases. No parallel processing. No parallel processing in most of the databases. If
What is parallel processing?
Okay. So yes. So just I'll give a labor example of parallel processing, right? In Hadoop, data will be distributed along multiple systems and multiple systems will be processing the data parallelly. The data or the huge file will be split into smaller parts stored across multiple systems and is processed parallelly. That happens everything in automated fashion. If you take parallel and non-parallel, you take example of non-parallel, a labor example, right? Non-parallel and parallel. One person preparing one item takes 1 minute. The same one person preparing 10 items takes 10 minutes. The same one person preparing 100 items takes 100 minutes. The same one person preparing 1,000 items takes 1,000 minutes. right? But in the case of parallel processing, one person, 1 minute only. Like one item, 1 minute only. 10 items, 1 minute only. 100 items prepared in 1 minute. 1,000 also 1 minute. Means here, parallel processing means 10 persons preparing the 10 items parallelly takes 1 minute. 100 people preparing 100 items parallelly, 1 minute. 1,000 people. So here we said persons, but in our terminology in Hadoop, systems, multiple systems will be running parallelly, right? So parallel processing. So here, if volume increases, if volume increases, right? Yes. Speed decreases. This, observe this. In databases, if volume increases, I'm saying speed decreases. For example, take this query, select total amount, sum of amount from sales one consisting of 10 records. Assume it has got 10 records. Again, one more query, select a total amount. Select total amount from sales to. From sales to consisting of 1 lakh. 1 lakh records. Sum of amount, right? From sales 3. 1 crore records. Sum of amount from sales 1, 10 records. Sum of amount from sales to 1 lakh records. Sum of amount from sales 3, 1 crore records. Okay, fine. Sum of amount from sales 1, 10 records. So here, sum of amount from sales to 1 lakh records. Sum of amount from sales 3, 1 crore records. So here, which query is going to execute faster among these 3 records, right? Which query executes faster among these 3? First or second or third? Which query executes faster among these 3?
First one. Yeah.
First one executes faster because sum of amount of 10 records as compared with the second query and third query, right? As volume increases, speed decreases and complexity increases, right? If complexity increases, speed decreases. So here, complexity increases, speed decreases means, for example, see this, select sum of amount from sales, the same query I'm taking. Excuse me. Select average amount. Average amount, right? From sales one. Select a sum of amount from sales one. Select average amount from sales one. Select standard deviation. Standard deviation of amount from sales one. Okay, all from one table only, sales one, sales one, sales one. Among these 3, which query executes faster? Total amount of sales one, average amount, standard deviation. Average amount is a 2-step process, right? First sum has to be calculated, next average has to be calculated. So as compared to the first query, second query takes more time. Standard deviation means lot of internal processing required. So query to query, as complexity increasing, speed decreases. Right? The major drawback with databases. The major drawback with databases, right? Right. Databases can handle only structured data. Databases can handle only structured data. Databases can handle only structured data, right? Databases can handle only structured data. They cannot handle unstructured or semi-structured kind of data. For example, okay, if you want to take the reviews for a particular movie, for example, there is a reviews, a table reviews. You got a table like this. In a structured format, you got a table. User and review. User 1 saying the movie is good. User 2 saying movie is bad. 1 means good, 0 means bad. User 3, 1. In this way, 100 people have given the feedback. So can you write an SQL query to count the number of ones and zeros? Can you write an SQL query to count the number of zeros and ones, right? Yes.
Yeah.
Try to say, what is that query? Count aggregation, right?
Select count from reviews where review equal to 1.
Select review wise count I want. Review wise count from reviews table. From reviews table, group by review. Okay, see the output for this. So review wise count means, okay, 1 and 0. For 1, review wise count from reviews group by review. Okay.
1 is 3, 0 is 1.
Review wise count from reviews group by review. Fine. For 1, okay. 90 people saying, okay, movie good, 10 people saying the movie bad. Now, so here review wise count from reviews group by review, right? Yes. So now, okay. Generally, the user won't give the reviews in the form of ones and zeros, right? Now, they will be giving the review in their own text format, saying that first person movie is good, second person saying movie is not good. So in this way, the reviews are given in their own text format. Now, can you write an SQL query to count the number of goods and not good? Can you write an SQL query to count the number of goods and not goods? We cannot, right? Even if you go with keyword count, still it won't give that because not good is also having good within it. It gives wrong computations, right? So here the major drawback with databases, they cannot handle unstructured and semi-structured kind of data. Yes. And what are the advantages of Hadoop? Just coming to this advantages of Hadoop, right? Yes. Before we go with the advantages of Hadoop, right? So Hadoop doesn't follow client-server architecture. It won't follow client-server architecture. Hadoop follows master-slave architecture. It follows master and slave architecture.
What is client server architecture and master server?
Okay, client server means if you give a request, giving response, web applications, right? Web applications, there client server, client giving the request, server giving the response. But Hadoop is not for that kind of. Hadoop is for Hadoop follows master slave architecture. So single master, multiple slaves. Hadoop follows master and slave architecture. Single master, multiple slaves.
How it is different with client server? Client server also one, and different clients are allocated to the server, right?
So here, clearly, like Hadoop is not for online processing, online applications. It is for batch applications. So whenever you online application means whenever a client gives a request, compulsory response has to be given. But here Hadoop is not for that kind of request response or client server kind of architecture. It won't follow. It follows master and slave.
Okay.
Single master and multiple slave. System 1, system 2, or system n. A number of systems, a number of slaves, we can say. These are all slaves, slave nodes. This is master node. This is slave node. So here Hadoop, for example, Hadoop data f1.txt. So here each system 1 TB capacity, assume it's 1 TB capacity. One TB, 1 TB, 1 TB. This f1.txt in Hadoop data is stored in the form of files in databases, in tables, right? In Hadoop, it is in the form of files, f1.txt, 2 TB file. This 2 TB cannot fit into S1 or S2 or S3, SN, right? So it will be splitted into smaller parts. Each part will be stored across multiple system or slave and will be processed parallelly. Means 2 TB file, right? A 2 TB file is distributed across multiple. Okay. Yes. 2 TB file. So, okay. So this 2 TB file divided into smaller parts. Here two advantages you see. Distributed storage and parallel processing. Distributed storage and parallel processing, right? Yes.
Just one question on this Hadoop. Hadoop is there from longer time, right, in the market. Right now we have a cloud. So why still we need to learn this Hadoop?
See here,
Why?
1 second. So we'll be this course is previously Hadoop was a separate course, Spark was a PySpark was a separate course, right? Now both combined because for learning PySpark there are some prerequisites of Hadoop, like scoop. If you want to bring the data from different databases to this environment, right? We require scoop component. There is one more hive component of Hadoop, right? Which used for data warehouse kind of processing, right? Data warehouse kind of for making the data structured. We use a language called HQL. We create tables, internal, external tables, and performing querying on this data. Whenever you make data structured, create table, and for that hive component is used. One more component of it. And for huge data storage and processing, HDFS. HDFS, right? And that is one, scoop is one, hive is one. These components, there are some components I'll be discussing in Hadoop, right? And my main discussion will be on Spark. Means very high speed processing, huge data in quick time. We are going to process this using Spark, right? Spark is a kind of processing, right? Technology. So it has got many APIs are there. Data frame, RTD APIs, where we can only write huge codings, right? Yes. Yeah.
So PySpark is not Hadoop combining tool. Huh? I mean, just I don't know what is this. Hadoop is a different vendor, and PySpark is a different vendor, and I mean, and just PySpark is a cloud technology tool, or how it is?
No. So PySpark is for processing the data. It is for processing the data, right? Huge data in quick time. Hadoop also can store and process the data, but currently Spark has got very high speed as compared with Hadoop, right? So I'll be just
Okay.
giving you some. I'll give you some examples now. The Hadoop as compared and PySpark as compared with other technologies. What is the speed you can see? This is only for processing. Spark is meant for processing, right? Huge data. And that too in seconds you can see the data, huge data, right? Today it
Yeah.
has got great boom where industry is expecting the results in quick time, right? So most of these ETL kinds of projects, they're migrating to this PySpark environment where we use some Hadoop components also in that, right? Okay.
Okay.
So
So
without PySpark, we can't use Hadoop, or both are mutual dependent between
So
each other,
no.
right?
PySpark, okay. Now currently mostly like PySpark is preferred, but for PySpark there are some prerequisites of Hadoop components like Scoop, Hive will be using it, right? So NHDFS. So that's why I'm saying that I'll be covering this Hadoop some components, right? And go
No,
to
no.
PySpark.
I just wanted to, like, if both are mutual dependency is there. If I'll not use the Hadoop, you can't use the PySpark, or
PySpark, you can go with PySpark without under at least like there are two components minimum you need to have the knowledge, right? But PySpark we can go individually also without Hadoop.
okay. So there's no dependency
Yes.
between them. Yeah.
So that's what I am
So
saying that two different, yes, two different
PySpark, it means like a Python Spark, you mean?
Spark implementation using Python, PySpark.
Python, okay.
So
So are you
Spark,
going to cover Java's implementation with the Spark also? No, right?
no. So Spark can be implemented in Python, Scala, Java, or language. So currently in the industry, like Python is mostly preferred, and even Scala also preferred. So we'll be discussing with Spark with Python implementation.
Okay, so who don't know the Python, they can be able to understand here, because I'm Java developer.
Not like that. So Spark with Java is very less used in the industry. Only like a company like Value Labs only that is using it. No other companies are using Spark with Java. So based on the requirements, tomorrow if you offer updating, you need to go with that, right? So if you see PySpark, a lot of jobs and also that huge packages with you can see the salary packages 1.5 times more than other technologies, right? Same way, you need to have the technical skills on this huge good command on this technology. So, okay, I'll come back to your general queries, right? First, let me discuss the advantages. I still didn't discuss the advantages for Hadoop Spark. So, drawbacks of databases, I said, right? So, here, master node and slave node. Master node assigns tasks, slave nodes executes the tasks. Master node responsibility, task assigning, balancing the load. Fault tolerance means in the failure of any system, if any system gets failed, right, any slave gets failed, that the task will be assigned to any other slave or system. That process we call it like fault tolerance, health monitoring. And slave node responsibilities, storing the data and processing the data. Storing and processing data. What is that? Slave node responsibility. So Hadoop advantages means unlimited data storage is possible in Hadoop. Unlimited data storage possible because of a feature horizontally unlimited scalability. Unlimited data because of a feature horizontally unlimited scalability. Horizontally unlimited number of slaves or systems can be added, right? Hadoop advantage mainly like unlimited data storage is possible and very high speed processing, right? Because of parallel processing and can handle all varieties of data, structured, semi-structured, unstructured, right? It's commodity hardware and open source, no licensing required, right? So these are the major advantages, the first three, right? So to see the speed of Hadoop as compared with other data sources, right? Other databases. Yahoo has taken a table of 100 TB size of 1024 columns. The task, what is the task, right? Sorting based on 16 columns. Sorting based on what? 16 columns. So what is the time taken by the different databases? Oracle has taken nearly 3.5 days to process this data consisting of 16 columns. MySQL MySQL has taken 6 days to process it. Teradata, where it can handle TBs of data, right? It has just taken 4.5 hours to process it. Netija has taken just 3 hours to process it. But finally, Hadoop has just taken 4.2 minutes. The latest version of Hadoop has taken just 2.3 minutes, right? Yes. Why databases like Oracle can't support unlimited storage? Means there is a limitation, right, for these databases. Databases also can go with max number of slaves or systems. Databases max limit on the number of slaves, means CPUs. Okay. Oracle can go with maximum 256 CPUs or nodes, right? Beyond that, it cannot support. MySQL can go maximum with 56 nodes, but MySQL Express can go with 256 nodes. DB2 also, SQL Server also with the same. Teradata can go with 512, but currently supporting 1024 CPU nodes.
What is node here?
Node means a system.
Okay.
Node, number of slaves or CPUs or nodes, I'm saying, right?
Okay.
Slave node. Net is also with 512 systems or nodes. Vertical.
So you mean to say that for one system we can attach only these many 256 systems?
Means in a cluster they can maintain only 1024 here.
Okay.
For this. But Oracle can see in real time. Oracle can go with the means storing of data. It can go maximum with 256 nodes systems, right? Beyond that, it cannot support.
Okay.
Means the performance of this Oracle degrades even if we have 256 nodes. If it is using all the 256 nodes gets filled, just like your internal storage of your mobile phone. If 64 GB means if all the 64 GB is filled, the performance of your phone degrades. Sometimes you don't even start. Same way here, Oracle, right? There is a limitation, a maximum number of CPUs they can interconnect, right? Right, but there is no limit on the number of slaves that Hadoop can have, right? Yahoo, when first time implemented Hadoop, it went with 4,000 slaves for storing its data. Currently, Yahoo going with 12,000 slaves or CPUs. Facebook, when first time implemented Hadoop, went with 8,000. Now, currently, Facebook going with 42,000 slaves for storing its data. Okay, so this is Hadoop has proven storage point of view and a processing point of view, right? Processing point of view, very high speed. Storage point of view, also like huge storage, right? So ETL kinds of projects, wherever huge data is involved, where that projects are migrating towards Hadoop environment. And if you see that Spark, right? You see that Spark, very high speed processing, even as compared with Hadoop also, right? Just introduction, I'll go give introduction to the Spark and PySpark. So yes,
So Hadoop is open license.
open source. It's an
Open
open
source.
source. Yes,
So there is no license is required in it, right?
no licensing. Most of the products are from Apache products. What is
Okay.
Apache's? What is Apache Spark? Why PySpark? So here already I've given, right? 1 second. Already we have wrote here in the starting. What is PySpark? What is Spark? Why PySpark? Need for PySpark. Real life usage of PySpark. PySpark job market, right? Yes.
Just one thing. Earlier you mentioned big data. Sorry, Hadoop will be having one is map reduce and another one is for processing. We'll
Spark.
be using
Spark.
so. Okay, I'm confused because so Hadoop internally is having one Spark
No. Hadoop internally has map reduce.
only. Okay, so because
Only
that time
Hadoop has
the
got
diagram you
only,
mentioned.
Hadoop has
Okay.
got only map reduce.
Okay,
Hadoop,
I thought in diagram you mentioned map reduce slash Spark. I thought it is Hadoop
means
related.
currently in the market still both are going, right?
Okay.
But mostly like if you want a very high speed, means in a simple way I can say, if you see this, right, Oracle has taken 3.5 days. Teradata has taken 4.5 hours. Netija 3 hours. Hadoop has taken 2.3 minutes. Hadoop has taken 2.3 minutes, right?
But this Hadoop has taken 2.3 minutes. I'm just understanding this is a storage area, right? This is not a processing area.
Processing only.
Oh, okay. I mean, because Oracle, how Oracle is having a processing?
See,
Because
sorting, right? We cannot, can you perform sorting or not using Oracle?
yes, I can perform. Then what Oracle internally uses for processing?
No.
Like Hadoop is
See,
using MapReduce.
can you perform this sorting based on 16 columns using Oracle, MySQL, all this or not? So for that, they have time taken to process this. Means huge, this much of data they need to sort. This much of data consisting of this many columns, they need to sort based on 16 columns. So what is the time taken?
Yeah, I understand, but I don't understand that one.
So in the case of databases, performing merging, grouping, sortings, aggregations, all are possible, filtering, all are possible, right? With this databases.
Yes, this databases it is possible, correct?
So
Yeah.
okay, that is what if I'm giving the task to this database, so what is the time taken, and what is the time taken by Hadoop comparison? So it is very high speed, right, as compared with this, and
Yes.
Hadoop has taken this much of time, right?
Yes.
And what is the speed of Spark? Spark is 100 times faster than Hadoop.
Okay.
Means observe that Hadoop has taken very less time here, and based on that, comparing Hadoop and Spark now, Spark is 100 times faster. That is in-memory computation. Means in Spark, the storage happening within the RAM, processing happening within the RAM only. Storage means in-memory computation we say in Spark. In-memory means storage means whenever you are trying to process the data first, it gets stored in the RAM and data processed within the RAM only.
I understand that Spark is faster, but I'm not able to correlate with why we are correlating with this one is Hadoop, because Hadoop or Oracle or these are our storage areas, right?
Hadoop,
So
Hadoop is a storage or processing?
Because it is having HDFS file system, which is used for
Hadoop
kind of storage.
Hadoop performs storage. Hadoop
And
performs processing. Both
so
it performs. Hadoop
I mean to
performs
say that
storage.
one earlier,
Hadoop,
the processing which is used by MapReduce was 2.3, but with PySpark it will be more fast.
yes.
Okay.
Hadoop is meant for both storing and processing. Spark is only for processing.
Okay.
So Spark still need a storage area, right, to be process the data, right?
So yes,
How do we process them?
so here
That
one
is one.
second. For currently, like we use Hadoop for storing and Spark for processing. Both combinedly used for storing and processing.
Correct. Yeah, that is why I think question
But
is there.
there are some companies who are using Hadoop. I doesn't means for Spark the infrastructure cost is more, right? Huge RAMs we need to maintain. Means 2 TB data you need to maintain. It should be stored in the RAM only, not in the disk. In Spark, your data has to be stored within the RAM level, not in the disk level. So companies which can afford to do that, right, can able to go with Spark. That's why it can achieve high speed because of in memory, right? So otherwise, it are going. There are companies going with Hadoop. Hadoop also has got very high speed, right? So people that companies which can afford for this huge infrastructure of huge RAMs. If you are able to store a TBs of file in Spark, right? Your RAMs, you need to have huge RAMs, right? Maintained in within that cluster level. Fine.
Hadoop using hard disk?
Yeah, Hadoop uses disk storage.
Disk storage. Okay. But the Spark using the RAM storage, but it will be at the runtime only. But after that processing the data, it will be destroyed, right?
Yes, yes.
Okay. So that the Spark still needs a storage system to be process the data. Correct?
It has to, yes, it has to take the input, right? So
Yeah.
where Spark has to take the input from some big data source like HDFS.
Okay. Okay. That's clear
Okay.
now. Yeah.
So it is like it will take the data from big, like any kind of storage, like
Yes,
HDFS system. It is going to take it and it will process it, and again it has to store into some other area, any disk storage.
into HDFS it can store or any other, right?
Okay.
HDFS it takes the input directory will be there, process it, and the output will be stored in output directory in HDFS only. From HDFS again, if you want to export it, you can export it. If you want to import or export, both can be done using a component called scoop.
Spark can be process the data from the Oracle, MySQL, and other DB.
Yes. See, what happens is the database one, your branch one, database two, database three, multiple branches, databases is there, right? Here we have got HDFS, huge storage, HDF, Hadoop distributed file system, right? You pull the data from this database, from this database, from this database, nearly from 50 databases, you will pull the data and store it at one place in HDFS. Where data, so from 50 databases or from 50 branches, you pull the data and keep it in the HDFS. And from that HDFS, we use processing. So this is storage and processing, right? So here that from HDFS, the data will be taken by Spark, process it. Again, it will be stored in the HDFS. From HDFS, again, you can take the data, the processed data from which is present in HDFS. Again, you can take it back to database. For that, we use a component called scoop. Scoop means SQL plus Hadoop. The last two characters SQ and Hadoop, the last three characters combined scoop. For scoop import, we say here importing from databases to HDFS. We use scoop. Again, for exporting also we use scoop. So this is the scoop knowledge you need to have, right? It's a component of Hadoop.
So
Why
you mean to say that one from
Pardon?
sorry, why this scoop is used as a extraction purpose from source to HDFS?
See, in HDFS there won't be any data. There won't be any data. From where you need to bring the data means from databases. Who brings the data means we use scoop.
Okay.
It pulls the data and scoop is a data ingestion tool which will bring the data, will pull the data from different databases, data sources, right?
Okay. And what do you have written in the top of scoop? SQL plus Hadoop. I don't understand what is it?
The full form of scoop.
Okay.
SQL plus Hadoop. First two characters taken from SQL, last three characters taken from Hadoop.
So it's a ingestion, data ingestion tool.
It is used only for SQL and Hadoop only, no other. The scoop is a component which is used for interaction between SQL to means a database to Hadoop and Hadoop to database, inflow and outflow, database to Hadoop and Hadoop to database. No other component. Scoop is for only for this database to Hadoop and Hadoop to database.
So in the current market,
here I am importing data, importing using scoop. After that, after processing the data, I am exporting and I will store on the database. I will display on the database website.
So for Hadoop, you mean to say that this is the only we have to use must. If I am using Hadoop, this is the only ingestion tool. Other than in the market, we cannot use any data ingestion tool for this purpose.
Flume Kafka is there for streaming. Flume and Kafka for streaming, live streaming data for live streaming data, right? Flume Kafka components. I'll also provide knowledge on this Flume Kafka, right? Data, live streaming data which keeps the data which is generating, right? Currently, that data also you can pull it into HDFS using Flume and Kafka.
So this data ingestion tool which we are using, Scoop, is it support for all kind of data like semi-structured, unstructured, and fully structured data, or it is there any limitation? This data ingestion tool
data ingestion tools. That's why I'm saying that Flume Kafka is the data ingestion tool. Scoop is also in Scoop. Scoop is what from databases you are bringing data means it will be structured, right?
Yeah.
Yes. Apart from that, from local file system to HDFS also you can bring files. LFS to HDFS, local file system from Linux. So
that
LFS
will be used as
LFS.
That will
for example, .csv file, .xml file, .json file, .xml file, .json files. Which
what will be the ingestion tool for this one?
So directly we have got some commands for that, for pulling the data from one file system to another file system. We have got some commands, copy from local, right? Copy to local, right? We have got some commands, HDFS commands for pulling the data from this one file system to another to HDFS file system. Means we have got .csv or .txt or .xml, .json, this kind of semi-structured, unstructured files also you can pull to HDFS. There you can process it.
So we mean to say that one only for structured data, only one tool, data ingestion tool between HDFS and inflow and outflow, we will be using the spoof, and semi-structured data, unstructured data, we will be using directly using the commands, and we'll load the data into HDFS.
Yes.
Okay.
And even
one question from my side. Why we need bring the data from HDFS to the DB2, because HDFS is also storing the data, right? So why we need exporting and importing from the DB? Importing, I mean to that you have already data, then you can import that.
I understood your query. Let me respond. See here, you have got an organization in 20 cities. 20 cities, I have pulled the data into HDFS here. Huge data, right? And there is a business logic to be implemented. I want to know only those customers whose balance is above 30 lakhs. Means some example I'm saying, right? So you are just going to process using Spark. After that, the result you get, right, you will store in HDFS. So Spark process the data based on some, means if you're getting lakhs of records, millions of records. After processing, you may get 10 records or 20 records. I want the top 10 customers, and I want to display these customers on the website. Means this from HDFS, you can export the data using Scoop export and to database. From the database website will on the website you can display that. Yes, the top 10 customers means from 20 branches you are pulling and you are processing and you are displaying the output on the website. Means if you want to export data also, we can export data from HDFS to the databases. and we can import
this
from
is
data.
extra. This is extra feature, but we can still we can store the data in this HDFS, right? If I don't want to be exported.
Yes. If you doesn't want to export, you can store in HDFS for later usage.
Okay, our application can directly communicate with the HDFS, like online application and all that directly. They can get the data from the HDFS.
So here, so from
Yes.
databases you are getting. So the HDFS is not for see this Hadoop or HDFS. These are not for online processing. They are for batch processing. Online processing means immediate pulling. So this is batch processing means huge data. You are pulling it and you are processing it. Online processing means what? For one record also, you need to process two records. Immediately one transaction happened. User has to give the input. So here millions of records. So Hadoop or Spark is good for huge data. For
so
small
online
data,
process, again we have to export the data in the DB, and then DB has to be connected with the application, right?
Yeah, data anyhow. DB means DB. The database is maintained for one particular sites or organization, right?
Yep.
Yes. And within that website, again, it can display the data from the database. Okay. So generally, why we why we go for PySpark means running distributed SQL for creating data pipelines. The output of one will be the input to the next flow. For ingesting data into database, running ML algorithms for graph and streaming, right? Right. So here, PySpark is the Python API to use Spark, right? So Spark is an open source cluster computing used for big data solution, right? So this PySpark is a lightning fast technology, right? Used for fast computation. It is very demanding tool for among the data engineers, right? To work with bigger data sets. It's used for these things. Yes. So, and what is the need for PySpark means today, if you see both through online and offline, data is generating, right? Huge data. The data contains hidden patterns, unknown corrections, market trends, customer preferences, user preferences. So I need to extract some useful information from that raw data. So we require some more efficient tools like PySpark, right? Means we have already got many tools available previously, but they are not doesn't have that much of speed and that are not so appealing, right? So we need to have some flexible tools to crack big data and gain benefits from it. So PySpark is such a kind of technology, right? Where we can achieve the speed, very high speed. Means even streaming data also can be processed by using this PySpark. Streaming data means live data. At one time the data events are generating, the other side the processing is going to happen, the events. The rate
that is also called OLTP, right? It's not batch processing data, we can call it as.
Rate of speed means for example, online your data is going to be captured from the data is going to be captured from the and stored in the HDFS. From HDFS, Spark takes and process it immediately. Means very high speed processing. Means at one side streaming of data means streaming is happening, other side processing is happening. This is not online processing. Online processing means immediately it should give response, but it is just process and gives the result based on the business logic, right? So means even for streaming data also this Spark does well, right? And even for machine learning algorithms also this Spark means a typical data scientist should depend on this data engineer, right? That means they need to have the knowledge of this Spark and Hadoop. Later comes this data science, right? Means on that results you are going to apply these ML algorithms, performs data analysis, predictions, clusterings, classifications, all this, right? Yes. So the combination of Python and Spark is the very efficient way for the world of big data. So Apache Spark community has come with a tool called PySpark, that is Python API for using Apache Spark. So here, what are the things I'm going to like I'm going to deal with some storage and some processing, like storage HDFS for processing Hive, Spark, and MapReduce. And for NoSQL database, I'll be showing you one NoSQL database like HBase. NoSQL database means schema-less behavior, random access. Today, like NoSQL databases also has got great boom. So I'm going to talk about HBase, right? And even Cassandra going to give knowledge on Cassandra also. And streaming technologies like Flume, Kafka, and Spark streaming. And in PySpark, PySpark core programming, PySpark SQL, PySpark streaming, and PySpark ML machine learning library, right?
NoSQL, are you going to cover MongoDB also?
NoSQL like HBase will be discussed and also part of Cassandra.
So NoSQL database means it is like a source NoSQL database where we are going to extract, or how it is?
See, SQL and NoSQL. SQL means structured. NoSQL means not only SQL. Means in the case of databases, first record to last record, same number of columns to be maintained. But in NoSQL database, my first record with 3 columns, 3 fields, second record with 5, third record with 10, right? Means record to record different number of fields will be maintained.
First, so it's like unstructured data.
Yes, first employee has got employee ID, name, salary. Employee 2 has got 5. Employee 3 has got 7. In this way, right? Like JSON type.
Okay.
Dictionary type.
Okay.
So that is
so,
one.
Here, what we are actually seeing, NoSQL data. From NoSQL database, we are extracting the data. That concept are we seeing, or what exactly we are learning here?
See the feature, right? The future database will be NoSQL database. Okay. Not like most the top 20 websites, the top 20 e-commerce sites, they use NoSQL only, not SQL.
Okay.
So in the coming days also, NoSQL, everywhere we'll be seeing NoSQL database instead of SQL database. Because SQL requires structuredness. Today, if you've got 4 columns, employee ID, name, salary. Tomorrow, I want to add new column. Every time I need to keep on altering the table using alter command. But in the case of NoSQL, directly you can add one record. So that is what in advantage. So even how we can handle this NoSQL database and knowledge on this NoSQL database, and also like streaming technologies like Flume, Kafka, and
these are technologies to bring data from streaming applications, or this will be used to bring the data from streaming?
Flume, Kafka are the technologies used to capture live streaming data.
Okay.
They are the technologies used for capturing live streaming data, and after capturing, they will dump the data into HDFS.
Okay.
And so are you going to cover these are the tools also, right?
Yes, yes. So Hadoop ecosystem components, HDFS for storage, MapReduce for processing, Hive also for processing. We use HQL similar to SQL, Scoop SQL, Hadoop, right? Import or export from databases to Hadoop and from the export, right? NoSQL databases like HBase, Yarn, yet another resource negotiator, means Yarn architecture, Yarn components. From Hadoop 2 onwards, we say like Yarn, Zookeeper, right? It controls and coordinates all the other components, right? And Flume, Kafka for streaming, right? And PySpark. I'll be discussing all this. And if we see the course content, right? Like big data, Hadoop, HDFS in brief, MapReduce, and Scoop SQL plus Hadoop importing. While importing data only, I want to match the data. I want to filter the data, group the data, performing various operations while importing. Yarn architecture, NoSQL database, HBase is one, and Hive. Lot of discussion on Hive. Means if you have got jobs only on Hive also, right? It's a data warehouse kind of environment in Hadoop framework. That's why I'll be spending more time on Hive, working with unstructured XML data, JSON data, URL weblog data, unions, UDF, UDTFs, partition, non-partition, indexing, multi-column indexing, right? Bucketing, right? PySpark introduction, PySpark RTD computations, persistence options, PySpark core computations, grouping segregations, various inbuilt actions, transformation one by one with various working examples, PySpark SQL data frames. So how to create data frame and the various data frame APIs with different inbuilt functionalities, one by one with many working examples. PySpark SQL functions and PySpark built-in functions, right? And PySpark external sources, PySpark deployment modes, PySpark applications creations, deploying and the drivers execution stages and tasks, PySpark streaming and integration with Kafka and PySpark MLlib, right? And this PySpark, I'll be showing you how to run in different environments, like on Yarn, on premises and on cloud premises, like Databricks, Azure Databricks. I'll show you right how we can do with it step by step, and in Python Jupyter Notebook. All this I'll be showing you step by step, right? So it's a 12 weekends batch, like 3 months it takes. Entire you will be getting great command on this entire Hadoop and PySpark for data engineering, right? So yes.
Is it like I just want to say Hadoop is there from long time in the market. Right now the cloud is coming into the picture.
So that's what the Hadoop previously we have got many components in that, only mostly used components for the project, right? For the for doing projects, what are the components which are mostly used? Those components I'm discussing, right? Not all. Previously, all the outdated components I'm not at all discussing. So what are the like Hive, Scoop, HDFS, these three. Previously, we used to have 10 components. All the other components we are not using today, right? So for doing a project, what are that Hadoop knowledge required? What are that? My total like 60 to 65% of the time, what duration of this course I'll be spending on PySpark. 60 to 65%. 35% I'll be spending on Hadoop and Hadoop components.
So how much time it is every week? Saturday, Sunday?
Saturday 2 hours, Sunday 2 hours, totally 4 hours. So it goes for 12 weeks. Sometimes in practicals, sometimes that if I'm free, I'll be extending that time, right, to 3 hours. I'll pre-intimate, right? Yes.
Yeah, you already have a real-time experience on PySpark might be. So are you showing any real-time projects?
So at the last, I'll be showing you one flow, right? Yes.
Hi, I just want to make sure like how you were, we see the curriculum right now. How will be the course structure, right? Will you be just explaining just a concept and picking up random examples? Are we just going with a flow of, for example, like say picking up a kind of project structure?
There won't be anything theoretical. Everything will be practical, right? Everything will be dealing with the practical point.
Yeah, in practical itself, right? For example, let's say when there is a
taking a file, right, and how we can perform the different types of operations. So in the case of Hive, how to create internal tables, external tables, loading data from local files, from HDFS files. I'll take a local file and I'll load it and show you. From HDFS file into Hive table, I'll just take a file and show you. Tables, how to create internal tables, I'll show you. External tables, how to work with unstructured data. I'll take one unstructured data. XML data I'll take and I'll show you. JSON data I'll show you. I'll take URL weblog data and I'll show you, right? I'll show the execution.
Because of what I was I'm expecting to have after this course, because currently I'm a data developer, 13 years of experience. So my currently with relational databases and some NoSQL, JSON and XML. But all I'm doing currently in on-premise side, I'm just using ETL tools. I would like to get into this kind of PySpark mode of processing large data sets where I'm currently having large use cases. I should be migrating my existing ETL process, which is processing terabytes of data using PySpark. So I'm hoping that after this thing, I should be able to implement this knowledge in my real-time use case.
Yes, definitely, right? Because today, most of in the industry, right, all these ETL kind of projects are migrating into PySpark environment today. So whenever you go for interview, they'll ask in Hadoop, they'll ask if you go for PySpark interview, still they ask some queries on Scoop. They ask even if you go for PySpark, they'll ask some queries on Scoop. They ask and Hive. They will ask some queries on Hive, and remaining all on PySpark.
Yeah, definitely. Yeah, I'm not looking for a kind of interview kind of definitely. All these concepts are definitely helpful. Yeah, because I wanted to implement this project in my current role. So That's why I'm definitely, that is my main agenda for enrolling into this course, to make sure that I extract this knowledge and implement this knowledge in my real-time application.
Yes. Yes. Okay.
So in this Sudhir only, right? Sudhir is using might be the existing ETL tool Informatica in his project. So he might be used Informatica mappings to transform the data from one source system.
Informatica, what version is used?
I'm just giving an example.
I'm using SSIS currently.
Informatica, what is the version?
No, I'm currently using SSIS.
Okay, SSIS. If you see Informatica 10 version, right? It has got a Hadoop plugins. Fine. It has got Hadoop plugins. If you observe it, if anyone working with Informatica, right? From 10 version onwards, you got the plugins with Hadoop, right? Fine. So once Hadoop has come into the market, right, the demand for Informatica has decreased. You see in the year 2006, 7, 8, 9, 10, 11, up to 12, right? Informatica has got a great boom in the market. Once Hadoop in the market, right, the boom from it has decreased. Now once Spark has come, okay, Hadoop, but still Hadoop components, some components are used in the projects, right? So that projects, that components knowledge and this PySpark knowledge will be provided in this course, right?
So overall, we can say this PySpark is like a ETL tool.
Yes, it's meant for processing as per your business logic.
And do we suppose if I am having only SQL knowledge, shall I go for this training?
Yes. So just basic Linux knowledge is required. Still, if it doesn't have, I'll be just briefing you about that basic Linux commands. And for understanding the HDFS commands and basic SQL is required. And basic Python knowledge, even if it doesn't have basic Python knowledge, the syntaxes of Python, I'll be just briefing you for, right? Before I go with the practical part of PySpark. Yes. So I handle Python batches also, right? If anyone interested, you can just also go for the Python batches also. So people who opt for this big data course, and even if they go for Python course, right? So they can no need to pay the full fees for Python, right? They can pay 50, means people for big data students, that is offer, right? By the DURGASOFT. If they opt for Python, means they need to, as Python is a kind of prerequisites for this. So if they want to go for Python course also, they can pay only 50% fees for the Python. So if anyone wants to attend Python also, right? Tomorrow, that is on Monday at 7 a.m. there is a batch, or from Tuesday at 10 p.m. there is a batch. Python batches, right? Morning, if you want to attend morning, 7 a.m. on Monday, and evenings means on Tuesday at 10 p.m. it's going to start. If anyone opts for Python, right? Fine. Okay, fine, right? Any other queries?
So are you going to cover in this some basics of Python here?
Yeah, basics. I'll show you all the syntaxes of Python, right? Like Python variables, collections, functions, all those things. Before I go, the syntaxes I'll be showing you. Yes.
Okay, I am already DurgaSoft like some other course I was doing. Do we get some discount for accepting this course?
So you can you see that in that okay? Can you observe here? There is a 1 second. Can you see a big message given by this online team?
I can't see your screen actually.
Not my screen, in the chart message. Like
okay,
payment, the chart, there is a message given, right? They have provided payment details, they are given, some contact details are given, right? So if anyone, if you already did any course in this DurgaSoft, right? If you want to have any kind of things, you can just yes, you can just call those numbers and for anything related, any discount, anything, right? But as of now, people who wants to go for Hadoop, if they want to learn Python, for Python 50% discount applied. But for other course, if you did, but still if you want some discount, you can call on these numbers, right? For the fees things, I cannot deal with those. You can just contact these numbers, right? And the course content is forwarded. You can just check this course content. So you'll be getting great command on this PySpark and Hadoop, right? Fine. So tomorrow also we'll have a session, right, at 7 p.m. right? And try to get enrolled by see the payment details, other things, right? For getting the videos daily basis, you'll be getting with videos, right? You'll be getting the videos of this.
So the video recording will be valid for some
6 months,
duration or
6 months.
okay.
For 6 months duration, it will be there. And
6 months is including the course or after 3 months?
so you
6
can
months.
so from the day you are starting, right?
Oh, that will be difficult, right? Because we understanding the course itself, it will be the near yeah. We'll check with DurgaSoft. That would be good if after the course
So
it
okay,
will be 6 months. Yeah.
if it's common to all the courses, right? For all the courses in DurgaSoft, it's 6 months. But thereafter, if you want to extend it or if you want to just extend it, you can just talk with the team, right? The front office after 6 months still if you want to extend, right? Yes.
So all the softwares will be, we have to connect to the system, or it will be installed in our, we have to install into our systems. We have to connect
all that I'll be demonstrating, right? I'll be whatever is there. I'll be forwarding some resources to you to your Google Drives and how to work on it, how to do all those things. I'll be briefing you, right?
Okay, thank you.
Okay, fine. So
how many demo classes you are going to provide here?
So tomorrow also you can attend, right? Tomorrow also you can attend to see more on this. And next week onwards we'll be we'll be going with that actual part. You need to get enrolled from the next week onwards, right? Tomorrow also you can attend the session, right? Today and tomorrow you'll be attending, but from next week onwards you need to get enrolled, right?
Yeah, but DurgaSoft, I'm also attending some of the other course. They are giving unlimited. There's no timeline to video recording actually. I'm not sure for this course. Yeah.
Video recording.
So yeah, recording. There's no limitation time.
So regarding the video recordings, everything you can talk with that office, right? Front office. But as for all the courses, it is for 6 months. You see, after 6 months, they will disappear.
Okay. So the meeting will be happen. Course will be training will be happen on Zoom only, right?
Yeah, in Zoom only.
Okay.
Fine. Okay, so I'm stopping for now. We'll continue tomorrow at 7 o'clock. More discussion on this, right? Yes. Okay.
So, just a moment. Just the last question. What are the prerequisites of the system to learn this Spark? I have 16 GB RAM. Actually,
so no, minimum 8 GB is required. Only the RAM 8 GB, minimum 8 GB RAM is required. If anyone doesn't have 8 GB also, just I'll provide you the many other means, right? How to work. Minimum 8 GB is that. Fine. That's it.
Okay. Sure.
Okay. Fine. Still, if you have got queries, you can ask me in the tomorrow session also. Same time tomorrow at 7 p.m. using the same link. More discussion on this, right? Yes. Fine. Thank you all for your time. Meet you tomorrow. Fine.
Thank you. Bye-bye.
Okay.